This is Algebra 2 with Trig. This is a worksheet, Unit 1A, 1B, second day's worksheet. We're looking at the domains from this table. The domains are your x values. So 1 through 5 has all been written one time. So that's our domain. The range, each time we plugged in the domain, we got the same result. So it's just a single number for the range. No need to rewrite repeated numbers. In this case, we have a graph. Our domain are all the x values that are covered throughout. So we're down here at -5. And the x value is going to be greater than or equal to, because it can equal -5. But it cannot equal +5 because that's a hollow dot. For interval notation, we can use -5 with a square bracket, and then we can use +5, the larger number, with the curved bracket because it does not exactly equal 5. The range goes from 0 all the way up to 6. From 0 to 6, it can equal 0, but it cannot equal 6. For graphing, in our notes we learned a little quicker way rather than the RST. We will continue to use RST with other types of functions. We can use the vertex, -4, -2. That's our vertex. H is -4, K is -2, and 1 is our slope. So we have our equation y equals absolute value of x plus 4 minus 2. How we can compare this? The parent function translated, 4 units left, 2 units down. There is no reflection, there is no stretch, just a translation. The domain for absolute value is always all real numbers, and the range is always from the k value. And in terms of interval notation, the end behavior. As x approaches negative infinity, which is to the left, the y value, or the function, approaches positive infinity. The graph goes up as we look to the left. As x approaches positive infinity, as the x gets bigger, the graph also gets bigger, and it moves to the right. Here we go -1, -6, with a slope of 2, and we have y equals 2 absolute value of x plus 1 minus 6. We know that it translated 1 to the left, 6 down, has a slope of 2 to the right, and if it moves 2 to the right and is our absolute value, then we know it's going to make a Z shape with the 2 to the left, or the negative 2 slope. The parent function has no reflection, but it is stretched by a scale factor of 2 and translated 1 unit left, 6 units down. So of course the domain is all real numbers. For an absolute value, the domain is always all real numbers. You can plug in any number you want to into the function. You'll always get an answer. The range, what type of answers do you get? You get everything from -6 and up. So with this graph, we start at -2, -3. We're going to graph with the slope of -4. So we know that our vertex is at -2, -3. It has a reflection and a vertical stretch. The translation of 2 to the left, 3 down. The parent function is reflected over the x-axis because of the negative in the equation. It's stretched by a scale factor we have a scale factor of 4 and translated 2 units left, 3 units down. The domain of an absolute value is always all real numbers, and the range is from -3 and down. Smallest number is -infinity, the largest number is -3. So notice how I changed the order. You always put your smallest number first. Square bracket because it can equal -3. Round bracket because you cannot exactly reach a negative in your calculation. So we have a vertex at 1, 5. Then we have our negative half slope, which is down 1 over 2, down 1 over 2, down 1 over 2. And we're going to look the other way also. Down 1 backwards 2, down 1 backwards 2. We have our parent function, and it's reflected over the x-axis. It shrunk by a scale factor of 1/2. And it's translated 1 unit to the right and 5 units up. So our domain is all real numbers, and the range are your y values less than or equal to 5. So our interval notation for our range would be the smaller number, which is negative infinity, and a larger number, which is 5. It can equal 5. It cannot equal negative infinity. The end behavior as we look to the left, our function goes down. As we look to our right, as we look to the right, the function goes down. We also have a scale factor to show you, end behavior over here. As we look to the left, this f of x looks to negative infinity. As we look to the right, the equation goes down. So notice that in the absolute value, the function is going to go in the same direction every time. It's either both are going down, or both going up. Here's an end behavior. You look to the left, and you see that your function is going up. You look to the right, and you see that your function is also going up. On the flip side, we're looking to see what equation makes this graph. This equation would open up because it's a positive a value, open up because it's a positive a value, open down because it's a negative a value, but the slope would be down 2 over 3, down 2 over 3, doesn't fall on it. This one is down 3 over 2, down 3 over 2, right on it. Down 3, backwards 2, down 3, backwards 2. So we write the equation. We see that it's opening down, and from the one point we know to the other point that we know, we're down 3 over 1. Its absolute value, because it's a V shape. It's negative because it's opening downwards, and it's 3 because of the slope to the right. So we read up 1 over 3. It's opening upward, so we know it's going to be positive. It's 1/3 because that's the slope to the right. And there's no h or k value because the vertex is still at the center. It's going down, so you know it's negative. The slope is -1. So instead of making it a 1, I'm going to call that an absolute value symbol. It goes 0 right and left, so there's nothing added to it. And it's up 2. There's nothing else added to the h value, so that's why it's 0. Here it's opening upwards, so we know it's going to be a positive. The slope is up 1 over 2, so you know it's a half. It's a V shape because it's a linear equation in both directions. It's been translated 2 units to the left, so it's +2, and 1 unit down, so it's -1. Number 11, write an equation of an absolute value function that is translated left 4 units and has a domain and range. This is our domain, which is very common. It's all real numbers. It's to the left forever and to the right forever. And the range has to be going down forever, but coming up to the number 7. So it's going to move to the left 4. Has a range that goes all the way to 7. That's what we're going to see. You know, it goes down because that's what the range is doing. We don't know what steepness it is, so we'll just call it 1. To look at the translation of 4 units to the left, x minus 4, or actually, sorry, remember it's the opposite, x plus 4 and plus 7, because the range goes up to 7. Our end behavior, when we look to the left, is falling down. When you look to the right, or you look to positive infinity, this function's also moving to the right. Or going to positive infinity. So this is called a cubic equation, and notice how they go in opposite directions. One way it's negative, the other way it's positive. But in an absolute value, or even a quadratic, they'll go in the same direction. If it's an even exponent, like a square is a quadratic, so it's going to go in the same direction. A 2, a 6, and 8 would all do that. But as we look to the right, it's increasing. Here we have weekly sales, and the sales are considered in thousands of a new basketball shoe, and it's going to increase steadily. The sales will increase for a while and then decrease. That's going to make a absolute value equation. So we're going to take our graphing calculator and we'll type in -2. You need to go to the math key, over to number, and absolute value is the first one. I'm going to type in x for my variable. I can't type in a t, but x minus 15. Arrow over to get out of the absolute values, plus 50. We can't see the whole thing. Well, let's look at what the equation says. It says it's opening downwards. It's been translated 15 units to the right and 50 units up. So in my window, using the window key here, I'm going to look, try to be sure you can see it with the glare. To the left, the negative or minimum x, not very important. The maximum x, we have to look more than 15. The minimum y, it's not very important, but the maximum y, we have to look more than 50. So it goes up a ways and then it comes back down. So our window we used, so we're going to use a minimum of -10 and a maximum of 20. And our scale is 1. That means how many tick marks they're going to have. They're going to have it 1 for every unit. The y is -10. The y max is 60. And the scale we used is 1. So what is the greatest number of pairs of shoes sold in a week? So by looking at our graph, we're going to notice it's way up here, which should be at 50. If we go to table, you'll be able to see that the largest number that this goes to is 50. And remember, this is in thousands, so it's 50,000 shoes. And we're going to get that in 15 weeks. We saw that from the table. So how could you have answered 13B without actually graphing on the calculator? Well, we could use the vertex, which is h comma k, which in this case would have been 15 comma 50. And we could have used the vertex to answer the question. Now remember, the y values are in thousands, so that's why it's 50,000. Look at this last one. How many weeks? At how many weeks were 30,000 shoes sold? Well, we look here. We have 48, and that would be 48,000. At 10 weeks, we have 40, which is 40,000. So at 5 weeks, looks like we have 30,000 shoes sold. And if we go down, we would get, at 25 weeks, we would get 30,000. So we could use second trace, which is intersect No, I did. I typed that before I typed in my intersection, my other equation. We could have typed in how soon until you get to 30. And you go to intersect. And is that your first equation? Yes. Is that my second equation? Yep. Move your cursor next to an answer you're looking for. Hit answer, and it tells us at 5 weeks we get 30,000. Now, for us to be able to see the other direction, we would need to look to the right more than 20, probably like 40 or 50. So now we're going to say second trace, and number 5. Is that my first equation? My second equation? And then move my cursor closer to the answer I'm looking for, and it knows which one I'm going to pick then. So at 25 weeks we get 30,000. So 30,000 shoes, we're going to use y equals 30 for this problem. Because the y values are in thousands. The function is in thousands. You could see the table for where y equals 30. And we get that to be 5, 30, and we also saw that to be 25, 30. Now another way we could have done it is algebraically, what we're going to learn in the future. We know we want the equation to equal 30. So then you have your absolute value. You add your 50, or actually subtract the 50. Divide by the 20, divide by the 2 to make 2 goes into 20 10 times. Now an absolute value has to equal a positive, so it does. We're all good. So we're going to take 10 equals t minus 15, add the 15 to the other side. And we're also going to have it equal negative 10 and add 15 to the other side. And there's the two answers, 5 and 25, just like our table showed us here.